Hey everybody, welcome to the OpenUSD Insiders live stream. As you can see, my great colleague, or over here I should say, Mike is joining me today because we have very special guests from Accenture. And Mike has been working with his team, and we're going to dive into how they're leveraging Omniverse for digital twin technology in real-time simulation, transforming industries. We're going to show a couple of really cool cases that they've been working on. Before we get started, Mike and I are going to go through a couple of quick announcements. Let me, if I could share my screen really quick. We've got an amazing this couple of events coming up that we have just announced. I think one of them was not just announced yesterday at GTC Paris, but we have another one in Taipei happening on May 21st to May 22nd. So we're going to put the link in the chat. There is early bird pricing for that ends May 7th. Super exciting. And there's also a keynote that's a part of that is going to be at 11 a.m. Taiwan time. So you can go to the website, which is in our chat, and you'll be able to add that live stream to the calendar. Obviously, for everyone else in the world that cannot attend that in person, the keynote is going to be available to everybody to watch live, or you can watch it after the fact. And I can only imagine that Jensen will be sharing some incredible announcements and news there. So super exciting. That's going to be May 19th. We have a couple of, I'm not going to share my slides right now because I'm working with one screen. So I'm going to basically just let people know what's going on. And Amelia, our producer, is going to be posting those links in the chat. And then we'll bring in our very special guests. We also have a couple of links we want to share. One is going to be a blog on how the digital twins are scaling industrial AI. And we're going to touch on some of this today, but we're going to put a blog post in the chat. We're also going to include, that directly relates to today, the talk that two of our guests gave at GTC. So you can actually watch their GTC session if you have not seen it already. It's currently available, as all of our GTC sessions now are available from GTC 2025. We'll also post some links for some community resources like our Omniverse Discord, so you can chat with the community. We've also created a thread on the Discord server, so you can actually ask questions after this live stream about this live stream and follow up with the community there that's watching it. So thank you for everyone watching live. Let's go ahead and bring in our very special guests. We have Elias. Hey, Elias.
Hey, everybody.
And we have Christian.
Hi there.
Thank you so much for joining us. And it's actually pretty late for you guys, so thank you for coming outside of business hours. Super exciting topic. Let's start with Mike actually and do the introduction. So Mike, you've obviously are no newbie to these live streams, but for people who might be jumping in the first time, can you tell me about your role here in NVIDIA?
Yeah, hey Edmar, hey everyone, great to be back on the live stream. Mike Geyer, I'm one of the product managers in the Omniverse team with NVIDIA. Just celebrated my 5-year anniversary with the company. My background is kind of engineering, manufacturing, design, software, and just been really fortunate to work with super sharp, super visionary folks my whole career, folks like Christian and Elias here. So yeah, super pumped to do the live stream today.
Well, we're good to have Mike. You've got great experience here because you've been working with this team for a while. So we're going to go over some really interesting use cases with KION Group and also with Scheffler. So we're really exciting. So for everyone just tuning in now, let us know in the chat where you're watching from. If you're working on any cool projects, feel free to ask your questions along the way. We'll try to hit as many questions we can during the live stream as possible. And then we can also follow up, like I said, on the Discord chat we started for this live stream. Okay, but we are going to focus on how the Mega NVIDIA Omniverse Blueprint is being leveraged to reimagine warehouse automation. So for that, we have these very special guests from Accenture. So Christian, thank you for joining us. Tell us a little bit about your role.
So I am a managing director in Accenture, specifically overseeing globally next-gen robotics departments. So we are incubating future technologies that power automation and robotics. I've been in Accenture the last 15 years, and I get to cross multiple industries and multiple clients. And I will say that I have been always working on applying AI for reinventing client business. And I truly believe that NVIDIA is pushing the boundaries of robotics and automation. I've been working on my first humanoid 10 years ago, the paper from Aldebaran. I will say that it didn't pass the years or didn't successfully meet the expectation, but I truly believe that NVIDIA and the new technology that we are featuring now with Mega and with Mike is definitely pushing the boundaries of future robotic success. So I'm really excited for this invitation and this opportunity.
Well, that's awesome. I mean, the technology is great, but the technology is nothing without really good use cases and people putting it to fantastic
right.
uses. So that's where you guys come in. So thank you so much for that. And Elias, so tell us a little bit about your role at Accenture.
Yeah, exactly. So I am taking care of all the robotic simulation topics. So I work very closely together with Christian. And one interesting fact I think you all don't know, I go way back with Edmar, actually, because way before the official Accenture NVIDIA partnership, we were pretty active on the Discord channel, because for developers, this is a really good place for, getting developer grade access to if you have a question and so on. Usually, if you don't find an answer anywhere, you look at Discord and there's a good chance of you actually finding an answer there. So that's some of our secret sauce that
That is so
about
cool.
here.
I know. I think that it's just a great community. Just overall, everyone is very helpful to each other. And honestly, the developers that are on the Discord server are just some of the best developers I've ever seen in my life in terms of their just interest in jumping on and tackling different questions. We have great weekly groups that meet on Isaac Sim and Isaac Lab and study groups. Anyway, Discord server is great to come to. I'll post that link. Thanks, Elias. It's great to have a long-term member joining us on the live stream showing off a project like this. So we're going to be diving into digital twins for industrial AI and warehouse automation. And I think, Mike, it would be super helpful to kind of lay the groundwork here and talk about what was leveraged here in terms of the blueprint, the Mega Blueprint. So before we talk about what Mega is, why don't we just touch on what a blueprint is for people who might not be aware?
Cool. Yeah. So anybody that's not aware, a blueprint, you can think of it like a technology recipe or a reference architecture. A blueprint is a set of instructions and example code for how to bring together components from NVIDIA technology stack. So a blueprint's not necessarily something you're going to copy exactly and put into production, but it's something to give you a jumping off point to go and develop your own solutions. You could use some of the blueprints and mix and match it, remix it with other blueprints, but it's really that idea of here's something that we've been able to cook up in our kitchen, and you can go and make your own version of it.
Amazing. So really just be speeding up the first steps, prototyping and otherwise. Awesome. And then what is specifically the Mega Blueprint focused on?
Yeah, so the Mega Blueprint is really focused on bringing scalable cloud-based GPU sensor simulation to large-scale robotic fleet testing. So what does that mean? That means that the world is moving towards more automation. Anybody that's worked in a factory or a warehouse understands that there's a lot of dangerous, dirty, tedious tasks, and there's a shortage of workers right now. And these companies that are running these facilities are looking for ways to automate. Automation means more intelligent machines, which means robotics. These robotics systems are generally developed kind of looking at the robot as an atomic element. And we haven't reached the point where we're able to test those as a system, as a fleet, as a team, working together. And so that's really kind of the core of Mega, but Christian and Elias are really going to do a lot better job explaining kind of how it's applied and all that. So.
Well, that sounds great. I think it's super helpful. And I see a lot of questions and comments coming in already, even from LinkedIn. So thank you for joining us today. Really excited to get the conversation going. And feel free to ask any questions you have along the way, and we'll try to hit them as we go.
Cool.
So let's dive into a little bit about what the industry challenges that you guys were trying to tackle here. I guess this goes to Christian. So there seems like some big problems here we're trying to solve, right?
That's right. I will try to share firstly my screen as a good Accenture guy. I like to use some PowerPoint. So let me 1 second time for sharing my screen and let me know if it is working as expected. Can you see my screen right now?
I can see your screen. It looks like the view is of this chat. So if you
you can't see my screen?
I see Elias's. I saw yours, but I saw yours our webcam view. So it might be
I'm
hitting
leaving
the wrong
1 second.
button.
So otherwise, I will make without getting to use the beautiful PPT slide that we have. But let me get to answer the first question. I mean, that what is the challenge today? We see a 50 trillion business for our client, and mainly the reinvention about the ways that we have been running warehousing, factories, and more broadly. The new adoption of automation is becoming like a massive challenge for our clients. We believe that today the transformation is not just an incremental change. There is a fundamental transformation on adopting future robotic solution. And robotic has been already there for our clients from more than a decade. And I think that it is nothing truly new, but what we perceive as a game changers is a level of intelligence that is onboarded in the robotics. And I think that's if you look about the physical robot, they started by using a very repeatable kind of technologies and just repeating and repeating again and again the same activities with a level of intelligence that is fairly low. The problem is that the complexity of the task, the flexibility expected from warehousing and the factories is exploding, because we expect to make more customized products. We expect to be faster in the execution. And of course, we are all expecting to increase the productivity. So there is clearly an expectation to increase automation. And today, we need to use the new generation of robots. Of course, humanoid is certainly a very physical version that is mind-blowing and very inspiring. But we have other form of robot that is standing today in factories and warehousing, such as AMRs, certainly drones, black robots, and others will be standing. The problem is, today we have been using multiple technologies to optimize the level of intelligence of those robots, and I think that's one of the successful way of optimizing the automation has been using data, and has been massively using how we can train robots by using simulation. So one thing that we see from the market is, of course, in terms of the end-to-end transformation, we see that the automation is going to happen from the beginning of a warehouse, so from the inbound to the outbound, becoming like a dark place with a limited numbers of human intervention, and having a more end-to-end process of automation. So let me try again to share my screen.
Okay, cool.
I have nice content.
And for anyone who might have missed that in the beginning, he said 50 trillion with a T. That is the size we're talking about here.
Yes. Is that working now?
Yes, I see it now. Here we go. Let me add to
exactly 50 trillion. And so this is just a picture that we use from one of our client, KION, where we can get to see that on the overall process within the warehouse, you have automation that could happen really from the incoming of the goods, for quality inspection, for automatic depalletization. So there is clearly a very large playground to start bringing more automation and radically transforming the way that we are operating specifically a warehouse. So one thing that we believe that is a game changer, and that I think that's where NVIDIA is an incredible partner today, is a way that we can make the robots and all automated solution smarter. We have seen a lot of waves of artificial intelligence from generative AI, agentic AI of today, but the future is clearly the physical AI. And we have been we are truly incubating and developing the way that the AI is meeting the physical operation. So this is a groundbreaking technologies, and the thing is that we believe that today we have an incredible chance of making the robot smarter. We know all those videos that has been recently used as part of the previous GTC. Making robot smarter is very complex. It is bringing a lot of complexity, and of course it takes a lot of time. And I think that the simulation has been already introducing the power of increasing the level of automation. I just would like to share one video that I like, because I had a dream when I was young about how I can get to learn faster. And I think that you know about this video. I
Oh
hope that
yeah.
you hear the sound. So it is clearly in my mind, and I would love to have in the future partnership with those new technologies in the future to get to learn a new language or driving a piloting an helicopter. I think that it is truly what is going on today with robotics. You can use simulation to be the place where the robot could start learning. They can start exploring. They can start developing solutions by themselves and rapidly getting those learnings to be spread across multiple robot operations. The beauty of the simulation is, of course, it is cheaper, it is faster for making the training of the robotics, and more importantly, you can parallelize. I believe that in the audience, nothing new. I mean, that you have been all exposed to these technologies, and you know very well about the power of simulation, and that's the reason you are certainly already adopting NVIDIA today. But I think that solving the problem physically for robot and making the robot smarter is one thing. But beyond a robot, you need to think about a fleet of robots. And this is quite another challenge about how you orchestrate all those robots together. So I'm a soccer fan, so I wanted to bring these videos for everyone just to understand that you can have the best player on the field. They can be an incredible players with the 20 years of experience on playing soccer. If they doesn't know how to play together, it doesn't make sense. And at the end, they will not strike. And I think that the robotic is bringing exactly the same challenge. We have incredible robots standing today, and that in the future will be standing in your warehouse, in the manufacturing, or in other spaces, and even in public spaces. You can have the best humanoid ever, the most expensive one. If it doesn't know how to collaborate with others, it wouldn't deliver the value, and it will never get to strike. So that's the power of Mega and the project we recently worked on with KION about how we can truly take advantage of the smartest robots, trying to optimize orchestration and making those robots working better together and increasing the level of intelligence. So I'm sharing my screen. I couldn't see if there is any question.
Yeah, there's actually one that just came in 1 second ago. So this is fantastic information. It makes a lot of sense. We've got a good comment here from Lucas. A greenfield project built from the ground up around the concept of modern robotics. What would be the biggest challenge regarding including modern robotics in brownfield?
I'm sorry, just 1 second. I'm just picking up the question. You said the question from Lucas, greenfield project of modern robotics. What would be the biggest challenge regarding including modern robotics in brownfield? I think that is exactly one of the challenge. I mean, that's bringing the latest robotics in brownfield is definitely one of the challenge of our client. I mean, that brownfield is a huge market today for our client, and it has to play with a lot of constraints about how you are going to deploy those robots, how you are going to prepare the deployment of those robots. How do you prepare the deployment of those robots without breaking the existing flows of operations? Stopping a production line costs millions. And one of the biggest challenges of our client is not necessarily bringing new robots or the latest robots. The challenge is how do you do it smoothly and in a very optimized way. Again, simulation and what NVIDIA is bringing on the table today with Mega and all the Omniverse solution is specifically to prepare this deployment and this pre-commissioning, virtual commissioning, optimizing the operation virtually, and bringing this on the ground and accelerating the ramp up of those robots.
Amazing. Well, that's great question, a great answer. Want to say also a big welcome to Lychee AI, who's there watching the stream. He's a great creator of tutorials and also very active on our Discord, focused around Isaac Sim and Isaac Lab. Thank you for joining us. So we've got also, like, as I knew would happen, I warned Elias that this was going to be an audience that would be very hungry for technical information. We're going to get into that next. So that's a call directly for you, Elias. So so let me see. So we have another another good question here I want to tackle really quick because we have probably some new viewers who are just jumping into this. Right now we're covering industrial AI and warehouse automation. But we got a good question about, if you're getting started with some of this stuff, and for simulation, what kind of training and source materials are available? So we have some great learning paths, as we call them, available. One is specifically for robotics, one's for OpenUSD. That's a great place to start. The GTC sessions are also a fantastic resource, including from our guests here. We'll post a link again in the chat so you can watch their really informative GTC session on this topic. We also have a documentation portal with lots of documentation examples, and we have the community Discord server. So lots of different places to go, in addition to the live streams for great resources. And let us know if you find any missing gaps that you think we need to fill. We're always on the lookout. But I would highly recommend the learning path for robotics and OpenUSD to start. Mike, did you have a?
Oh yeah, I was also going to plug build.nvidia.com, which is where you can find all the blueprints and examples of the stuff we're talking about today with Mega. So if you go to build.nvidia.com and search Mega, search robot fleet, you'll find one of the blueprint samples for Mega. But that's a great place to get started as well, Edmar. Yeah.
Okay, that's great. Yeah, good call out. And another similar question to the last one we got, this one from LinkedIn. The world is moving more to automation, but in many regions, warehouse operations are still largely manual, with basic non-AI automation in place. Do you believe Omniverse can still provide value and insights on these more traditional settings? I think I think the answer is definitely yes. I think it kind of depends. What I often see, especially going to conferences and talking to other companies, sometimes it's overwhelming, right? To look at like, oh, a digital twin, oh my God, how can we do this for? But I think it all matters exactly what you need and prioritize and just scale accordingly. But what do you guys think on this?
You're right.
Sorry,
yeah,
go ahead.
This is a very technical audience. This is really good. These are great questions. These are exactly the questions that we also look at that get to the core of the issue. I wonder if it makes sense, Christian, for you to quickly introduce the KION case that we then, can always use the KION example as a reference to talk more in case we have some viewers that may are not that familiar with the warehousing context, that we have some examples that we can use.
I agree. We stepped really on setting the stage on terms of business and in terms of the technical challenges and the business challenges that we are trying to solve. But I think that the KION demos is answering most of the questions we can see that pop up on how we are bringing automation and how we are orchestrating better the human workforce and the robotic workforce. So let me try again to share my screen, and
okay, cool.
That will be working as expected. So 1 second.
Okay, yep, here we go.
So let's start by 2 minute videos. That will be first introducing the nature of the project.
KION, the supply chain solution company.
You know what? I actually have it. So, wait, is this the same one I have, Amelia? I have a cleaner copy of this. I have a cleaner copy of this video. Let me play this from StreamYard. It'll come out better.
Center market.
So let me remove this for a second. So Christian, you could stop yours and I will play mine, which I think this is the one we've got.
Okay, so there is no sound. I'm sorry about this.
No, there was sound. It just didn't sound too clear. I think this one is a sharp one. Let me play this.
Okay, cool.
KION, the supply chain solution company. Accenture, a global leader in professional services, and NVIDIA are bringing physical AI to the $1 trillion warehouse and distribution center market. Managing high-performance warehouse logistics involves navigating a complex web of decisions influenced by constantly shifting variables. These include daily and seasonal demand changes, space constraints, workforce availability, and the integration of diverse robotic and automated systems. And predicting operational KPIs of a physical warehouse is nearly impossible today. To tackle these challenges, KION is adopting Mega, an NVIDIA Omniverse Blueprint for building industrial digital twins to test and optimize robotic fleets. First, KION's warehouse management solution assigns tasks to the industrial AI brains in the digital twin, such as moving a load from a buffer location to a shuttle storage solution. The robot's brains are in a simulation of a physical warehouse, digitalized into Omniverse using OpenUSD connectors to aggregate CAD, video and image to 3D, LiDAR to point cloud, and AI-generated data. The fleet of robots execute tasks by perceiving and reasoning about their Omniverse digital twin environment, planning their next motion and acting. The robot brains can see the resulting state through sensor simulations and decide their next action. The loop continues while Mega precisely tracks the state of everything in the digital twin. Now, KION can simulate infinite scenarios at scale while measuring operational KPIs, such as throughput, efficiency, and utilization, all before deploying changes to the physical warehouse. Together with NVIDIA, KION and Accenture are reinventing industrial autonomy.
Amazing, and spoke very well by Jensen there. Really fantastic overview. And for everyone watching again, I have to plug the GTC session that Christian and Elias did. Again, the link's in the chat, but you should really watch that following this live stream if you have not seen it already. That would really be very insightful for you. But yeah, Christian, thank you. That was great. Great idea to show that one.
Probably a good chance to give a big shout out to our friends at KION Dematic as well. Really just a tremendous partnership and really close working collaboration. Many late nights for the European team and early mornings for the American team, and all sorts of stuff in between last fall and winter. So really a fun project.
Amazing team. Yeah. That's fantastic. Very cool. Okay, so we have some more comments coming in. I see our great producer Amelia has been sharing some resources in the chat. We'll be sure to add these to the video description. Also, if you're watching this after we're live, we have. Let me see. So so as I mentioned earlier, I'm going to post the link really quick. People can see it. The link is really easy. Just do a search for Learning Path Robotics, and this will probably come up on your search right away. It's great courses that are continually being added to regularly. So let me see. So here we've got. Here's a good question, kind of a high-level question from Thomas. And then I promise we're going to get into the deep dive and more technical stuff with Elias here in a minute. Do you guys believe the synthetic data will lead to a robotic GPT moment in the next couple of years? In other words, is the main problem for robotic advancement machine learning or physical problem right now? It's a
years or months?
Yeah.
Week, or is it weeks, Elias?
Yeah, I think high-level questions I hand over to Christian.
Smart man.
You can only lose on these answers, you know.
Well, we could skip to the next question, but I think it's anyone's guess, right? So we'll see how. But I think one of the most important things you could do is try to keep up on the news. And I always learn so much from following people like yourselves on LinkedIn to share great information along the way on the journey. I think that's one of the best ways to keep on top of what's current. And of course, attending great conferences when they're here. Like I said, I'm at the Robotics Summit right now, in Boston. I'm excited to see what's on the floor here today. But I think these kinds of experiences and talking to developers will with many great insights, and also those chats on our Discord server. So I'm curious to see what people think about that.
Yeah, I don't want to sidestep the question, but I think it's like you said, Edmar, it's tough to tell, but it's coming fast.
I mean, I have to say, like, feel free to disagree with me, but I have been literally blown away by how fast things just in the last 12 months from the last GTC we had in 2024 to GTC 2025 in terms of not only the number of companies and developers that were working on robotics, but also the advances in robotics from the hardware and the software side of things. It seems like it was pretty significant step. A lot has happened in 1 year. I don't know if you guys agree.
I agree, and I would like to bring a comment. I think that's, if you look about previously on robotics, you had a very high coupling between the software and the hardware sides, leaving only the people who have been working on robotics hardwares and that having the robotics and mechatronic experience and the studies to truly develop on robotics. The thing is that the technologies and AI is helping on that front, but the decoupling between hardware and software is definitely allowing a larger population to start developing on robotics. And the level of knowledge about how the mechatronic and how the physical robot is working become less critical beyond the way that you can build simulation, and you can learn from adapting this simulation and AI directly in the robot. So I believe that there is an acceleration because of the technologies, and the simulation is definitely helping with synthetic data and creating a smarter robot. But I think that we have a way larger population that would have access to robots hardware that it was previously the case a decade ago. So I think that it is a conjunction about multiple trends that makes robotics in a clear acceleration those last days.
Yep, good point. And another related question is, and there's no easy, quick answer for this. It really depends on what you're doing. But how long will it take to build such a simulation? So, like again, it really depends on the scope of what you're doing and what you're trying to achieve. But you don't. I think the key thing is you don't have to do everything at once, and you could just look at to see what exactly you're trying to do. And you also don't have to figure this out on your own. Also, I guess it's worth noting, you have great companies like Accenture and other developers in the world that are helping to make some of these decisions. So that's kind of what this is all about.
Yeah. And if sorry, Mike.
No, go ahead. Go ahead, Christian. Yeah.
I just want to bring that simulation is very broad, because we have seen the videos with a lot of Omniverse, but the level of simulation, the depth of the physics that you put in your simulation is another factors of complexity. You can have just a very photorealistic place of your warehouse, and pretending that you're running a first level of simulation of your warehouse. The level of simulation that is currently going on, and the relationship we have with Mega and KION is all about getting to the physics simulation that require more efforts upfront, and of course delivering way more values. But if I can share my own point of view on the question, is that you don't need necessarily to always run a full physical simulation for the full entire warehouse.
Right.
You can segregate the warehouse in multiple places and bringing more sophisticated level of simulation for specific place. Like if you like to optimize the depalletization automation, you can just specifically optimize, get the physical simulation for these specific areas. Or if you like to specifically for AMRs. So it depends on what the problem you would like to solve, and putting the right level of depth on the simulation that's against the problem you are solving.
Great point.
Not the question, but I mean, the answer is very complex without having more details about what we would like to solve with the simulation.
Yeah, it's definitely a journey, and you don't have to do it all at once. But you do got to have a few ingredients: a digital twin, robot control stack, a trained robot, and can kind of build out from there.
Amazing. And this is a question that is also pretty interesting to me. How does Omniverse help in factories such as where there's chemicals, less hardware in robots, more liquids and emulsion companies of gases? So I know, Mike, you have a good answer for this. I know that one of the examples we have for digital twin is of the data center, and in that data center example of a digital twin, there's definitely we're showing air movement, obviously for cooling. So there's definitely a way to bring that kind of stuff in, but I don't know if any of you guys have more thoughts on that.
I think you nailed it, Edmar. I mean, the thing we think about is connecting expert systems and making that connected environment accessible to more people. So we're not trying to do the fluid simulation in Omniverse. We're not trying to do any of the engineering domain specific stuff. You think of Omniverse as really the place to bring these domain specific models together, infuse AI, and make the insights and the information you can extract from that system more accessible to everybody else. So you can think about Omniverse as a way to build a 3D dashboard of the production data. The P&ID stuff, or process and instrumentation type plants that you're talking about, that's a super complex problem, but you could just start simply laying out equipment, right? Determining space constraints and looking at how the piping fits into the building, and connecting these data models that might not fit in other systems in there. But I'm curious, Elias or Christian, kind of what you guys think.
We also have a suggestion here from the chat from Scott Dempsey,
yeah.
actually. Yeah, so Warp is actually a fantastic tech to look into. We have a channel dedicated to Warp. Miles Macklin and the team are actually very active in helping developers. So I would definitely take a look at Warp, which has had some good advancements that were announced at last GTC.
Awesome. Warp allows you to use Python to program CUDA kernels, and that is like a superpower.
And just from a few minutes earlier too, I want to circle back to this, but Christian, you have a fan here from BMW. This is John Mitchell. Great explanation, Christian. Crawl before you walk, then run like hell. You have to hear that in John's voice. John is great. If everyone I highly recommend you follow John on LinkedIn. He's one of the Omniverse ambassadors, actually. Okay, great. So I'm looking at the clock now. As always, time flies by when we hang out with really cool and fun people and talking about really interesting topics like this. I want to make sure I'll leave enough time for Elias. And because I know we have developers here that are watching and want to see kind of how do things work under the hood when you're doing this. So Elias, would you like me to share your screen?
Yeah, that would be good.
Okay.
And I think it's actually a great setup because I really like the ChatGPT question because, for me, it was also very surprising on, this technology. I mean, I was even working in this tech, but even when I saw how good it was, I was still really surprised. And it's the same here, I think, on the robotic space where, there's so much changes with what you can do with Mega, what's coming up with Cosmos, what you can do in Omniverse, right? And so we ourselves, together with KION here, together with Scheffler and another example, we just discover like all these things together, and find out what's actually possible.
Yeah.
And often we find out, there is even more than we thought in terms of application. And there's a lot of stuff in the pipeline that we need to still explore. And to double click on the KION case. So in the interlogistics, there's a lot of potential that you have there because there are so many interconnected systems. I mean, forklifts are robots, so they drive around, they send data, they are controlled, and they have several control systems on top of each other. You have the robot stack, then the robot stack is controlled by some kind of a fleet manager. Then the fleet manager may feed in the information to the warehouse manager. The warehouse manager may feed in this information to some kind of subsystem, So you have a lot of systems actually involved in the warehouse that all need to work together and also need to be synchronized together and so on. If we look at a system at a scale like this, then an Isaac Sim wouldn't be able to cover all this because, I mean, an Isaac Sim runs on your server machine, and you do kind of quickly reach the maximum of your PC. So there's a limit on how you can scale Isaac Sim instances. If you want to have 30 robots in Isaac Sim, controlled down to the, on the sensor level, so you have for each robot, you have the synthetic LiDAR, you have the synthetic RGB data, and so on. It's a lot of compute that's happening on this lower level. And then you're not able to find a setup that is that powerful. And so that's the niche that's one of the topics that Mega tries to address. And so for me, this Mega topic is always a bit, because it's such a large vision, it has so many applications, we try to break it down a bit. There was a talk last week, 2 weeks ago, I think, from the Mega team. So Dave Elliott and the team, and I really recommend that talk, by the way, because it's really good.
Yeah, this is kind of considered part 2, I guess.
Yeah, exactly.
Cool.
And so this might be a bit of a recap for everyone that didn't join there. How does Mega fit into this, Omniverse world that you're maybe familiar with? So you have this, for example, USD Composer. If you want to create a USD file, you may want to use USD Composer. If you want to train a reinforcement learning agent, or imitation learning or something, you would use Isaac Lab. Or if you have a smaller scale system that you want to develop, for example, you have a robot that has a ROS stack, and you want to, configure that ROS stack on the robot, you would want to use Isaac Sim. And you can test also in Isaac Sim to a certain degree, but on Isaac Sim, you cannot scale. And then that is the mission, that's the idea on Mega. So Mega is a headless, server-based CI/CD platform where you can push then your entire, like your different robot stacks all together on Mega and test them there. And then if you find something is not working, you could go back to the to Isaac Sim, for example, so if you find, for example, the robot is crashing into things, then you could go back to your control stack and reconfigure the robot that was driving into a topic. And so then I quickly go.
One note, we got to update this slide because rather than USD Composer, that should be Kit App Template. So this idea that, you know, there are Kit App templates. It could be a Kit App template you build based on the USD Composer example or the USD Explorer example, but going, you know, kind of consistent with that idea of the blueprint. Just a slight tweak there, but yeah.
Yeah,
sorry
thanks,
to
Mike.
interrupt.
Yeah. And then maybe one double click on Mega, the slide you may also have seen before. This is, we also have a more in-depth slide, but this is maybe a bit of a higher level abstraction. So what you have is you have the robot brains, which is basically the control stack. Then you have the world simulator, which is defining how things are moving through space. And then you have sensor RTX, which is rendering the sensors. And why this is important. So the underlying technology is not too different to what you know from Isaac Sim. And so it's not really new tech, but it's connected in a new way. So that's my understanding on what a blueprint is. So it's a connection, a different connection. And what is sensor RTX separation to the world simulator? So if you would combine world simulator and sensor RTX, you may have something similar to Isaac Sim. But if you separate them, you can run these compute tasks also separately. So you can have a dedicated GPU for a specific sensor, and then you're not limited by the size of your GPU, but you can spread out the workload through all the GPUs that you have available in your system. And that allows you to scale to a much larger setup. Okay, so we have a bit more time. Then I go into a few examples what this means.
Amazing.
A robot brain. Here you can see, for example, a Turtlebot robot. And what would be a robot brain in case of the like purple Turtlebot? This would be the raw stack. So you have the thing that's getting the sensor information as an input, and then is giving you the torque values for the wheels as an output. And you know, this compute entity that's deciding based on the input, the output, that would be the brain. And but that could be a lot of things. So this can be a raw stack. This could also be some kind of reinforcement learning agent. This could be, so it really depends. It's all these decision makers basically that decide better based on the input, the output. And then on the world simulator, we actually have a video here with a small collision at the end. And what you will see here, so if you have your sensors that are attached to the robots, they need to wander in space, of course, that you get a new, like every simulation tick, that you get a new frame, a new picture. And so that's why we have the world simulator, so that the sensor knows how to move. And then each simulation tick, the new position of, for example, the LiDAR or RGB sensor, or you can see the collision here. So this is like collisions and these topics, this is all part of the world simulator. And then sensor RTX is maybe the hard piece of the Mega platform. It's also something that maybe you're not familiar with. This is where all the sensor rendering is happening. So for example, these robots have a lot of onboard cameras for different reasons, and also LiDARs and other sensors. And all these are rendered synthetically in on sensor RTX. And how this looks like for you is you start a simulation instance, or you send out a scenario, and this is then being rendered in your on your Mega platform, and then you can download all this data after it had been rendered. So that's what you can see here. And so then to double click a bit into the previous picture, you can also have this in a bit more detail on how the inputs and outputs actually look. But it's not it's nothing really fancy. I mean, it's cool and it's new, but it's not. If you take it like this, it's actually very simple. It's just a different combination on the systems that were previously existing, and that allow you now to scale to a much larger for much larger use cases, like we do for KION, for example, where we really have the vision to, at this warehouse, to simulate entire scenarios, not only one robot driving through some aisle, but like having multiple robots connected with the fleet manager and all these things. So going much, much larger than you could do before. And so this is then enabling this. And so, on the questions on like, what does it mean to interact with a brownfield environment? There's a lot we can talk about, but we only have here 14 minutes in the live stream left. So I give it back to you, Edmar.
Very helpful.
Are there specific questions that we should?
Yeah, so we have somebody here. I'm looking at, we have a question from, let me see, from Telly. I'm not familiar with this one. Maybe one of you guys are. We have a digital twin with FlexSim. How can we match it with NVIDIA solutions? Looks like Elias, you might know.
Yeah, so there is a connector between FlexSim and Omniverse. And so that's one question that we work on quite often. It's many companies have already their existing simulation journey or simulation flows. For example, they use FlexSim as a discrete event simulator to make layout decisions or something like this. And so you have already all this 3D data, and you may want to connect this to Omniverse, because Omniverse could be the place where you bring all your 3D data together, because it has very strong visualization capabilities and also other capabilities that, for example, for AI training and so on. And so it might be very cool to connect those two into one workflow. But it's also a bit of a dedicated topic. So it's a few things to consider.
Go ahead.
If I may, I think that's, again, Omniverse is not duplicating discrete event simulation, neither just making a photorealistic version of your discrete event simulation. So discrete event simulation are incredible solutions. We mentioned about FlexSim, Minilogic, visual components, Technomatic. So the list is fairly long. They all adopt the connectors to Omniverse, because it brings the simulation to the next level. The discrete event simulation will be solving process flow problems. So they will size the numbers of AMRs. It will help to really optimize the layout of a warehouse, of a factory. So it really helps to really accelerate and optimize a first instance of your warehouse. For me, the benefit of Mega, what is truly a game changer, is that it allows to have an optimization of the operations. You can constantly optimize the behaviors of your warehouse, of your factories, against the numbers of scenarios. So if tomorrow you would like to increase numbers of AMRs, you can simulate this in Mega. If you want to change the layout, you can virtualize this in Mega. If you would like to simulate an increasing numbers of inbound that is happening, you can simulate in Mega. If you would like to make smarter the humanoid standing in your warehouse, you can use Omniverse and using Mega. So I think that's, again, we are not trying to, there is no intention to duplicate the effort. It's more to bring the simulation and the numbers of optimization to the next level. Discrete event simulation is fairly disconnected from the operations. It gives a lot of learnings and optimization information, but after when everything is deployed, discrete event simulation is not continuously helping and supporting the operation. Whereas Mega can constantly analyze new scenarios, making simulation, providing new data, new information that could be consumed through an agentic AI or through an orchestration layers to constantly adapt the workflows and delivering the highest productivity results.
That's super awesome, Christian. Really, really well articulated. I would just add, from the NVIDIA perspective, the reason Mega is a blueprint is we want it to be valuable for all developers and be something that could be incorporated in software from any vendor, from any system integrator, any company could take and reuse it how they will, and that's really the idea behind a blueprint. Is, you know, this is not a product or a SKU. This is a set of reference capabilities, and those capabilities could be folded in whole or in partial. I think the way Christian articulated that's just really perfect from the NVIDIA perspective. So.
And if you need one more reason to try Mega, here's from community member Papa Chuck. He just wanted to use it because it has a cool name. So I don't know who's involved in the naming, but yeah, it is a cool name. So I agree with you there. Well, thank you for joining us. We still have a few minutes left in this live stream, so we're obviously covering digital twins for industrial AI and warehouse automation. Feel free to post in the chat if you have any questions or comments. We've been sharing some resources along the way, and great comments, feedback throughout, and great information by our presenters here. We have I guess more of a comment than anything else from Matthew Gill, who would love to see automated. What he would like to see automated is use of AI and Gaussian splatting with colorized point cloud data, automating cleanup and rendering 3D mesh models. Any feedback on this?
Yeah, we also would like to see that.
Join the club.
But yeah, but there's a lot of problems that we need to tackle, especially in the brownfield environment, right? And one is, how do you quickly generate a warehouse that's also functional, you know? Because there is one thing is to have something that looks nice, and one thing that also can connect with the robot stack and so on. So it's a big topic, but Gaussian splatting may or may not. Yeah, we have some ideas on how this could be included in the future, but currently I believe this is still an open topic.
There's some pretty interesting research. I'm not sure how much of it is public, so I won't speak to specifics, but our research teams are doing some pretty interesting exploration here as well, and definitely understand that need to go from scan of an existing as-built facility into something that can be used to train a robot or a robot fleet is super important. I've got a question for Elias, if we could, Edmar.
Yeah, please.
From a robotics developer, what's your advice on how to get started now to be ahead of where things are in 6 months and 12 months?
Yeah. If I say join Edmar's Discord channel,
that looks like we planned it. You can't say that.
No, so the way I do it, so I actually keep up on the Discord channel just to know what people are doing, because there's a lot of developers that post, you know, how do you integrate humans and so on. It's not filtered by some marketing filter, but it's actually developers doing actual stuff. And also, you know, sometimes complaining if something is not working, which for me as a developer is very helpful to know, okay, what is actually mature tech? What can I do? And then for Mega and all these topics, I think with the tools that you have available, like Isaac Sim and USD Composer and so on, many of these topics you can already do. And there's a few other providers that allow you, even if you don't have a GPU machine, to allow you to use these kind of services already today. So even if you are like a student or a researcher, there's already some ways that you can use Isaac Sim already today. It's a bit of a learning curve, I would say. So USD is very powerful in this entire cosmos. So I think it takes some getting used to. There is a ramp-up curve, but then it's also a very powerful tool set that you have available. Yeah.
And good comment there. Great presentation from Matthew Gill, talking to Christian's and Elias's presentations here. So I have to agree. And we have another comment here from someone on YouTube. Any books or references to get started soon? So we've been sharing links throughout the live stream. So I would, if you joined in late, scroll back through the live chat. You can see lots of great resources there we posted, and we'll try to add as many as we can to the description of the video afterwards also. But in summer, I would definitely do a search for Learning Path Robotics, Learning Path OpenUSD. Those links should come up pretty quick. And those are great free self-paced courses to help you. I think Elias, who's I guess now in our marketing team here at Omniverse, is plugging the Omniverse Discord, which is also a great place. I agree. We mentioned this in the beginning, but the amount of developer support I see is just really phenomenal. Really proud of the community we have there. who are contributing their own time to help others. And we also have weekly study groups that meet on Isaac Sim, Isaac Lab, OpenUSD. Those also happen either on Zoom or on the Discord, but all organized on the Discord server. And I think, I met with a student earlier today from University of Delaware, actually, who was attending the conference to learn more. So again, I would say attend conferences as a student. It's a great place to network with other companies and developers, and could help you with your job search later on. University of Delaware, actually, just while I'm mentioning it, they just spun up a robotics program. Really excited to learn more about that. And they are leveraging Isaac Sim and Isaac Lab. They also mentioned to me in that meeting that they would love to see more examples on getting started. So I'm going to bring that to our team here, and we'll make sure that we do take that feedback very seriously, and all feedback from the developer community is super helpful. So thank you. I think he mentioned specifically, like, how do you get from really step zero to one. So that really those first steps as a brand, and I think a lot of sometimes documentation in general always assumes a certain level of prior experience. So we definitely are very aware of that, and we're working to improve that all the time. We have a great team here that thinks about that all day. So keep the comments coming. Okay, great. So we have another great comment here. Fantastic sharing education. Thanks a lot. Do you guys want to leave with any closing words of wisdom? I know we covered a lot of ground here. I mentioned earlier and put in the chat that people should definitely check out your GTC presentation, which is very informative. And then obviously, yeah. So do you guys have any words of wisdom here?
I can give my own takeaway maybe for the session. I think that's primarily get to focus on the business first, business problems to solve first. I see a lot of people are excited about Mega Omniverse. It is an incredible solution, but doesn't solve the world by itself. And there is an incredible kind of problem that you can solve with Mega. But let's firstly start by the problem you would like to solve, and gradually starting to understand what will be the journey for using Mega in that exercise. I will say that Mega is an incredible solution for increasing the level of orchestration of automated and human workforces, bringing certainly more flexibility in the operation, and supporting the transformation about bringing more automation. That will be good starting point for the problem you can get to start solving with Mega. And last point, I already said a couple of times, but I think it is very important to keep bear in mind that NVIDIA is a true partner. KION has been an incredible client, but the success of everything that we have achieved results in the way that we have been running this project as a one team. And I would like to again thanks Mike and his team for this incredible support, because they are not just played as suppliers of technologies. They have been truly putting the skin in the game and supporting the incredible work with KION and Accenture. So I think that is for me very important to highlight. We don't have just a supplier of technology, but a true partner. And that thank you again, Mike.
Thank you, Christian.
That's so great to hear. Lots of great comments. I'm putting them on the screen. We want to remind everybody there is a Isaac Lab study group happening today, actually, a short time now on the Discord server. Look at this comment from Papa Chuck. And the funny thing about Papa Chuck, he actually does teach also this tech. He actually has commandeered a Panera Bread weekly, and they have a study group that meets at the Panera Bread. And they basically, no joke, I'll have to show a picture next time. He brings in desktop machines, surge protectors, extension cords. They're running this over booths and then doing basically a workshop. People working on robotics, and they have some small robotic hardware there. So anyway, he says the documentation is going to be so awesome. Even my grandma going to be using Isaac Sim. So we'll see about that. I don't doubt it though, because he's a great teacher. I'm sure your grandmother is very smart. Well, thank you, everybody. This has been really a fantastic hour. It flew by, and thank you for staying up a little extra late, Christian and Elias. And I really appreciate your insight in this whole conversation, Mike. Very nice to go over what Mega is, what blueprints are, and this great use case for industrial AI and warehouse automation. I hope this was insightful to everybody. By the looks of the chat, it looks like it was. But the conversation does not have to stop here. Feel free to go to that chat we have on the Discord server. If you go to events and live streams, you'll see this live stream has a thread. Feel free to use that. And until I see you on Discord on the forums, thank you everybody for watching. I'm going to run over to the Robotics Summit now and see if I can get some pictures to share on Discord later. But thank you again, everybody. Really, really helpful.
Thanks, Edmar. Thanks, everyone.
Thank you.
Bye.
Have a good night, Elias and Christian.
Likewise.